All right, everybody, in the interest of time, sorry about the short break, but I'm sure you all have your beverages and whatnot with you anyway. So now we're going to have Justin Koper. We've had Justin here a couple of times already. He's the Continuous Improvement Manager for HealthNet Aeromedical in West Virginia and a YSU graduate. So he's going to be here talking to us about landing zone operations and helicopter utilization. So thanks for coming tonight, Justin. I appreciate it. Take it away.
Yep, not a problem. Thanks for having me. And like Matt said, we're going to talk about landing zone safety. This is something that really isn't talked a lot about in the EMS circle. This is something that a lot of fire departments discuss. But we've seen even in our own response area with our aircraft that there's been an increased reliance on EMS to set up landing zones based on volunteer fire department availability and short staffing at career departments. So it's still an important skill to know for traditional EMS because you may be the ones responsible for setting up your own landing zone. And then as soon as we finish this one, we're going to talk about some utilization criteria for helicopters. So why would you call one in the first place? And hopefully at that time, we'll be pretty much close to 9 and not too much over. So just a quick little background about our program, who we are, where we came from, where we're going. We were formed in the late 80s as a kind of coalition between the 3 academic medical centers within West Virginia. We are a 501c3 not-for-profit organization. We are academically based. Our headquarters are down in Charleston, West Virginia. And then these are the hospital systems that comprise our board of directors. Charleston Area Medical Center in the Charleston, West Virginia area. Cabell Huntington Hospital in the western part of the state in Huntington, West Virginia, where Marshall University is. And then WVU Medicine based in Morgantown, West Virginia. And WVU Medicine is kind of like the UPMC of West Virginia. They're an extremely large, very progressive academic medical center. So we have the benefit of a program being owned by these medical centers because they do invest a lot in our clinical technology and safety. So big thanks to them. You may see some flight programs that are coming to your landing zones, and this is just kind of an interesting point of knowledge if you don't realize it. A lot of helicopter air ambulance programs actually don't employ their own pilots and mechanics. They're usually a contracted vendor. Now, Stat Medevac actually has their own FAA certificate and they operate their own, but a lot of programs use an FAA vendor and we use Air Methods. So if you ever see an aircraft that shows up, example is Med Flight of Ohio or Metro Life Flight, you may see Metro Aviation stickers on their aircraft, and that's their aviation vendor. Like I said, we're based throughout West Virginia. We do occasionally go into Ohio. Our Moundsville aircraft in the Northern Panhandle is dual licensed in Ohio and West Virginia, soon to be 3-state licensed in Pennsylvania, along with our Morgantown aircraft. So we do mutual aid to surrounding states and then also throughout rural West Virginia. We're going to talk a little bit about our fleet because our fleet is kind of varied. We have 3 different models of aircraft within our fleet, and that kind of mimics what you're going to see locally in the Trumbull and Mahoning County area. We have 3 EC-145 helicopters, 2 EC-130s, and 4 EC-135s. To put this in context, if you're getting UH Medevac, which is now operated by PHI Medical Aviation, you're going to see EC-135s coming from that operation. If you're getting Metro Life Flight, they're going to have EC-145s. And if you get Stat Medevac, they may have a 135 or 145, and that's kind of the same through Allegheny Life Flight out of Pittsburgh. So it just depends on which program's coming to respond to your location. That depends on the type of aircraft you're going to get. Having some broad familiarity with the kind of aircraft that's coming is a little bit important because each has their own limitations when it comes to patient size and weight. Each one has their own quirks on how patients are loaded and some of the restrictions on medical devices that are applied on the patient. For example, some aircraft, especially the 135s, if you have an extremely tall patient that has a hair traction splint on, they may not be able to fit the patient in the aircraft and get the rear clamshell doors closed because the patient's feet are so close to the back doors. That extended length of the hair traction splint might present an issue. So there's some clinical considerations based on the type of aircraft that are coming. And when we talk about setting up an air medical evacuation, there's some important pieces of information to relay so that way the air medical companies can make an informed decision on which aircraft they're going to send to be able to accommodate your patient. The EC-130, you guys aren't too familiar with this in the Youngstown and Warren area. This is something that's utilized by MedFlight of Ohio fleet-wide, and we only have 2 of these left within our system. One is in Prestonsburg, Kentucky, and one's in Huntington, West Virginia. It's a single-engine turbine helicopter, has a significant amount of weight carrying capacity, but it's only in our less mountainous regions. We tend to keep twin engine aircraft in the more mountainous regions of our response area. The EC-135s, you are probably very accustomed to seeing this. If you've had a helicopter on a scene that you've been on before, this is probably the most common air medical aircraft in the United States. Twin engine aircraft, pretty decently fast cruise speed, not a ton of interior room, but it's extremely popular amongst helicopter EMS providers. This comprises the majority of our fleet, and that's located throughout West Virginia, up all the way through Lewisburg, Millwood, Buchanan, and Martinsburg. And you see the IFR there. We're going to discuss that a little bit later when we talk about weather minimums for aircraft and why you may be told, we can't come to your scene here because of weather, but we can go here. IFR means instrument flight rated. So all of our aircraft that are twin engine aircraft are certified to do instrument flights. And I'll tell you what that means here in a little bit. And then the largest aircraft in our fleet are the EC-145s. This is what Metro Life Flight out of Cleveland uses exclusively. They used to use Sikorsky's way back when, but they switched to 145s a number of years ago. And also Allegheny Life Flight and Stat Medevac utilize these. This is kind of our version of our heavy lift aircraft. I personally have taken 600-pound patients in this aircraft. Depending on the crew and fuel load, we can do those types of transports. This is also a very common aircraft for specialty flights, such as PICU and NICU flights. So these are kind of the more capable, more specialized aircraft, and we have them spread throughout our system to accommodate that. I'll talk about reasons for requesting an aircraft in the subsequent lecture, but to kind of give you a point of contact, point of reference, so to speak, in West Virginia, we have state-run medical command centers, and that's actually where our dispatch centers are housed. So that kind of streamlines the process a little bit, where you're making one phone call to both medical command and helicopter dispatch at the same time. So that kind of streamlines the process for the field EMS providers. In Ohio, we don't quite have that. In Ohio, there is no state law that says you have to call the closest aircraft. It's whoever you want to utilize based on patient necessity, where the patient's going to be transported to, and all those other factors. So that adds a little bit of complexity for you as the field provider. The best thing that I would suggest in the instance of calling an aircraft as a field provider in Northeast Ohio is to follow whatever your protocol says. If your protocol says that you have to contact medical command or anything before requesting an aircraft, by all means follow that. But I would let your dispatch center, your local 911 center, be the one to coordinate calling air medical agencies and trying to figure out who's coming, because they're going to be the ones coordinating any fire department response to that landing zone. And they're probably going to have a little bit more information on what landing zones are close to you. So I would definitely leverage the support from your local dispatch center to assist you in getting an aircraft when you don't have things like a state-run medical command center. And this is just an example of how the state of West Virginia is set up. The green region is all covered by West Virginia University Medical Command based in Morgantown, and then there's a few other medical commands spread throughout the state. When you're thinking about calling an aircraft and you've determined that your patient necessitates it, or there's some other criteria in which you're considering an aircraft, we would definitely prefer, and I'm saying this as a flight crew member, I would prefer going to a designated landing zone. These are landing zones that are already pre-arranged within your community. And if you don't know if there's any in your community because you're a private EMS service or a private ambulance, reach out to some of the fire departments around you. I guarantee that they have some landing zones set up within their response area. And it might be good to get copies of those put in your ambulance. So if you are in a community that you're not too familiar with, and you know you need to fly a patient out, you know if there's pre-designated landing zones in and around that area. Our program, when we respond to a designated landing zone, we kind of train our flight crew members that when they're on approach to the landing zone itself, they kind of are taking mental snapshots to see if anything has changed since the last time we've been there or if there's any new hazards. So that way we can update our landing zone books. We know that the designated landing zones, if it meets our seal of approval, it meets all the requirements for safe helicopter operations, and they're in our dispatch center's database. So there's common names for these. So if you're in Leavittsburg, Ohio, and you call Metro Aviation and you say, I need a helicopter at Tom's Farm, if that's the name of the landing zone in your landing zone book, in the dispatch center book, and in the helicopter operator book, then they're going to know exactly where that is. You don't have to worry about coordinates. They're just going to verify that that's the correct location, but they don't have to relay that information. So designated landing zones are the easiest for us as flight crew members because they're in our database already, so it kind of takes out a lot of guesswork. Now, we will land at non-designated landing zones, and we do that all the time. So if you have a motor vehicle accident with heavy entrapment, by all means, let's not worry about setting up a landing zone 17 miles away from the crash if you're on a 5-lane highway that's already shut down, and it's perfectly fine to land right there, right next to the point of injury. So we will gladly land at non-designated landing zones, but if given the choice, we prefer to go to those pre-designated sites. When you're setting up a non-pre-designated site, so you're kind of setting up an improvised landing zone, this kind of goes without saying, we want a flat level surface. Helicopters have very specific limitations on slope, both front and back and side to side. And this becomes an issue if we shut down on the site. Because during startup and shutdown, the rotor blades actually begin to droop just because of the weight of the rotor blades. And if we're on a significant enough slope and those rotor blades are starting to kind of flap in the wind as the blades are slowing down, we can actually risk a rotor blade striking the tail of the aircraft or some other surface if we're not on a flat level surface. And also, if we're exceeding the slope limitation of the aircraft, we can't start the aircraft because of that risk until we get the aircraft on more level ground, and that's going to require a mechanic to come out with equipment to move the aircraft. So if it's a surface that we don't feel confident landing on, it may look flat to you, just based on what you're seeing. Don't be surprised if you see us kind of hovering around the landing zone and kind of evaluating different surfaces. We may even set down skids very lightly a few times if it's on very tall grass, just to kind of get a feel for what's underneath that grass that we're not seeing before we commit really to landing on that surface. And if the surface is not usable, we're going to depart that landing zone, go back to up to a high orbit. We'll coordinate with the landing zone command person and tell them that that landing zone is not suitable and we have to find something else. Now, when that happens, our crews are trained to identify alternate landing zones in and around that area. So if we identify that that landing zone is not suitable because it's not flat enough for us or not level, or there's a slope that exceeds the aircraft limitations, we have a really high vantage point, and especially in West Virginia, it's very tough for ground providers because in the next valley over may be a perfectly good landing zone, but because it's not within line of sight, because it's in the next mountain valley, they may not see that. In Ohio, it's a little bit easier with some of the terrain being more flat. You definitely have a better vantage point of landing zone possibilities around you, and slope is less of a concern. But when you're landing in the mountains of Appalachia, slope is definitely a big concern for us. We want low-cut grass, concrete, or asphalt. I will say concrete is by far the preferred. Asphalt in the summer when it gets super hot. For any of you that are motorcycle riders, I'm sure you carry a small piece of wood, a can, a block, or something that when you put your kickstand down on your motorcycle, you set that underneath the kickstand so it doesn't sink into the asphalt, because when it gets extremely hot, it gets soft. Well, I guarantee you a helicopter weighs more than a Harley 1200 Sportster, so it's going to sink into that asphalt, and could become an issue, especially if it sinks unevenly. And not only that, even if it doesn't become an issue for the aircraft, we don't want to cause damage to anything on the ground. So if it's extremely hot and all that's around is blacktop, we would prefer not to land on that. Also, don't try to land us in extremely high grass, because if you can't see the ground itself, we can't see what's within that grass. So if there are stumps, logs, debris, trash, fence posts, other hazards, we are never going to see those based on the height of the grass until it's too late. So we prefer not to land in extremely high vegetation, because it's an extremely high risk kind of operation for us, because we don't know what's in there. Avoid loose dirt or powdered snow. I'm going to show you an example of what we call it a whiteout and a brownout. Whiteout with snow, brownout with blowing dust. That's an extremely hazardous thing for both flight crews and for the people on the ground right next to the aircraft. If it gets bad enough, we will lose reference of the ground and really not be able to see anything around us or below us. If we get into a situation where we start to white out or brown out, and you'll see examples of that, we will immediately start pulling power back in and abort that landing. And I'll probably say about 9 out of 10 times, we will refuse to come back into that landing zone, because if we white it out once, it's going to happen again. It's too high risk of an environment. We're going to have to find an alternate landing zone. Avoid muddy areas or fresh cut fields. We don't want to be sucking up a ton of grass into engine inlets, and we don't want to sink into the mud. We want at least 100 feet by 100 feet. And if you're having a multi-aircraft response, you need an additional 100 by 100 area for each additional aircraft. When we go back and look at the dimensions of each helicopter, they're usually around 40 feet from the tail to the tip of the front rotor. So about 40% of that 100 by 100 landing zone is going to be occupied by the aircraft. So that leaves about 30 feet in the front and 30 feet in the back. 30 feet seems like a lot, I mean, when you're thinking about it, but that's less than one aircraft length. So if there are obstructions around us, we definitely prefer having the largest LZ that you can manage, because that guarantees the highest margin of safety for us. And the other thing, we want to have an approach path into the landing zone. I know helicopters can take off and land vertically. That's kind of what makes them the best thing for air ambulances in rural and confined areas and off airport locations. But believe it or not, helicopters hate doing a high performance takeoffs straight vertically or descents straight vertically. We can get into a situation called settling with power, and that's when, if we're doing a straight vertical descent with no airspeed, we can actually have our own rotor vortex come back into the rotor system and cause us to enter essentially an uncontrolled descent, that the more power you try to put into the aircraft, the worse the descent gets, because you're increasing that rotor vortex. So we definitely prefer to have something more like, and let me go forward a few slides here. We definitely prefer to have something more like this, where we're making a forward approach into the landing zone and we're not just coming down straight vertically. This does a few things for us. One, it keeps there enough airspeed that if we have an issue, we can fly out of that approach without being too committed to landing at that landing zone. If we're doing a straight vertical descent into the landing zone, if we see a hazard, depending on how much altitude we have left, we may be committed regardless of what's going to happen. And we don't want to be committed to a landing that's not going to turn out great. So we prefer to keep some forward airspeed because that gives us options. So in our single engine aircraft and in our twin engine aircraft, if we have an engine failure at extremely low altitude, the one thing that's going to help us immediately is kind of having some forward momentum and forward airspeed to help keep that rotor speed up to kind of cushion the landing. If we're coming straight vertically, we're not going to have that, so we prefer not to do those. This is an example of a whiteout that's starting to form. And you can see the aircraft here has some forward momentum. It becomes extremely problematic when the whiteout is progressing past the tail of the aircraft and coming up to the doors, because as we start to descend, we're going to descend into that. And you would think that, oh, well, looking at what the pilot can see, you still have a very, very clear view of things. The problem with whiteouts and brownouts, are that they develop very, very quickly, and they persist for a significantly long time if you're hovering. And when you're hovering, if you're encased in this cloud of snow, you can't tell if you're drifting forward or back or side to side or descending or ascending when you're operating at really, really low airspeeds, because your instruments aren't really valid when you have 0 forward airspeed. So this becomes really, really problematic, because if there's a set of telephone wires or telephone poles near us, we may not know that we're drifting closer and closer to those until it's too late. So that's why our crews and pilots are trained that if they encounter a whiteout situation that they can't manage, they're to pull power and get out of there, and ideally not come back into that landing zone just for that risk of having an additional whiteout. And this is an example. This actually occurred in Africa, but this shows you how quickly these brownout conditions develop. So a second or two after it started, we're completely occluded, and this is the view of the aircraft. You can't see the ground. You have essentially no reference outside, and that's how long it persists. So when you're a flight crew member trying to identify where the ground is and where hazards are around you, it can get really, really dicey really quick. This type of situation here, there's a slide in here that says we do not require charged hose lines from the fire department, and I'll verify that. That's not a requirement for us to land. But this is definitely a situation where if you have the fire department on scene and we're going to be landing in an extremely dusty environment, have them pull a booster line and just wet down the area. As soon as they start spraying down that area, that's going to knock down all of the dust that's going to form in and around the aircraft. So if we're landing at a baseball field, at a school or something like that, or areas that are extremely dusty, have the fire department spray down the area really quick. And it doesn't require a ton of water, just enough to get the surface of it wet to make sure that that dust doesn't fly up around the aircraft. The other big thing is you need to have a consideration for the direction of the wind when you're setting up a landing zone. We want to land into the wind. That's when the helicopter is performing its best. Helicopters do not like landing with a tailwind. So when the wind is kind of coming from the back of the aircraft to the front, that causes our tail rotor to do some unexpected things. And if we have certain, we call them quartering tailwinds. So if you have a tailwind coming from like the back right corner or the back left corner, we can actually have something called loss of tail rotor effectiveness, where the wind is coming from a certain direction and interacting with our rotor wash, and no amount of pedal input to the tail rotor will counteract the spin of the aircraft, and you can actually enter into a spin that's unrecoverable. So we will, if the wind is strong enough from the tail of the aircraft, we will refuse to land from that direction. We'll kind of do a 180 and be landing into the wind. So when you're setting up a landing zone, pay attention to what direction the wind is coming from, because we're going to be coming directly into that wind. So that way it gives us the best optimal performance. The other thing, if you know that the wind direction is this way and we're going to be approaching this way, do not place vehicles shining headlights into our approach path. Place them to where they're going to be shining at the tail of the aircraft as we come past. This is going to be important at night when we're using night vision, because those bright lights are going to wash out our night vision and essentially render it useless at a certain point. When you're marking the landing zone, we would prefer that you use LED flares. Those are by far the best. You can use weighted cones, just a personal suggestion, just lay them down before you set everything up and have the helicopter come, because they're going to blow away regardless. So lay them down so they don't catch too much air. Chem sticks, I would not suggest using those just because they're very, very light and they're going to blow away. LED flares are by far some of the best. They're extremely low profile. They tend to stay in place. Vehicle headlights, we'll use rotating beacon strobes and vehicle headlights to help identify where the scene is at. And then once we have identified the landing zone and done our high recon to see what obstructions are in the area, we're probably going to have you shut off all the emergency lights and headlights and just conduct our approach a little bit more in the dark, because that's going to give our night vision the best chance at working. And this is just an example of an LED flare. So it's just a simple little hockey puck style thing, battery powered. Just set one of these on each corner of the landing zone to kind of designate the area with which we're landing. And that kind of shows us the bounds of where we should be operating in and around that landing zone. Definitely do not use road flares. Just as a point of reference, you cannot have any open flame, lit cigarette, anything within 50 feet of an aircraft, whether it's running or shut down. If you have a road flare, that's definitely an open flame, and it's probably going to be within 50 feet of the aircraft, and we're probably going to blow it somewhere and cause a fire. So do not use road flares for marking the landing zone. Additionally, do not use caution tape. That really sucks when those things come up into the rotor system. If it gets caught up in the rotor system or on the aircraft anywhere else and causes damage, or even goes into a rotating part, that aircraft is essentially a paperweight until a mechanic comes out to inspect it to make sure there's been no damage caused. So we're not going to do your patient much good if we damage the aircraft on landing with things like caution tape or other lightweight objects. And this is actually an example. What you see on the screen here is the aftermath picture. Yes, that aircraft has the skids completely spread and it's resting on its belly. This was Metro Life Flight out of Cleveland about two and a half years ago. They were departing their base for a flight. So pretty much the most routine phase of operation. They were departing an airport location. At that airport, they were doing some construction, and they had that black construction netting set up on an irrigation channel that they had just dug to prevent some erosion into there, and that actually got caught up into the rotor system. And this just gives you an example of how fast these things happen. So they went to take off from their dolly, which is just that elevated helicopter platform. As soon as they did their hover check to make sure everything was functioning, they did a pedal turn to start their departure. As they started getting forward airspeed, the netting on that irrigation berm flew up and actually got caught in the rotor system. You can see right there, and caused them to make an immediate hard landing into the dirt. That is literally all it takes to put an aircraft on the ground in an unexpected fashion. So it may seem trivial when we say move that caution tape or move that debris. Helicopters, they are kind of enigmas of physics. They only fly because they're so ugly the ground repels them. So if you have an aircraft coming to your location and it seems like the flight crew is being especially particular with what is around that landing zone, these are the reasons why. It does not take much to cause a catastrophic failure like this. Now, thankfully, all the crew members walked away from this completely uninjured, but Metro Life Flight was out of a $7.5 million helicopter because of this while it was getting repaired and inspected. The other thing that we have a lot of concern with when we're coming into a landing zone are wires. These are fatal to helicopters. If you have a wire strike to certain parts of the aircraft, no matter what you do, there is no recovering from that. So wire strikes are often fatal in our business. They're very, very dangerous. They're easy to see from the ground. So a lot of ground providers, when we do this landing zone training, they think it's extremely self-evident that we can see a power line because it's extremely easy to see from the ground. A lot of people don't believe us that they're extremely hard to see from the air, and I'm going to have examples of that. The best idea that we have come up with on how to mark power line locations or other overhead wires is to park apparatus, ambulances, or other vehicles under the wires if possible. So if you tell us there's wires running diagonally across the field, park a police car or an SUV or something underneath those wires, directly underneath them, facing the same direction that the wires are going, because we'll be able to easily identify where those wires are and which direction they're running to and from. The other thing is to identify poles at night. If we see a lone telephone pole in the middle of the field, we are going to assume that there's a wire coming off of that pole in some direction that we cannot see, and we're probably not going to land in that area until we can identify that there are no wires coming from that pole. This is a wire strike on a Tor helicopter, I believe in Hawaii. Thankfully, nobody died in this incident. They were at relatively low altitude and were able to conduct a forced landing. But wires do not readily break when you hit them. They're braided steel, so they have a lot of tensile strength. And a helicopter running into them probably isn't going to break them too easily. It's often the rotor system that causes the wire to break, or it gets caught on a sharp surface underneath the aircraft as it goes under. The danger with wire strikes is the front of aircraft are extremely aerodynamic. So when you hit a wire at the very nose of the aircraft, it's going to go one of two places. It's either going to go up into the rotor system, or it's either going to go down under the aircraft and get caught on the skid tubes. Into the rotors is not ideal because you can lose rotors after that wire strike, and a helicopter without rotors isn't very effective. And if it gets pulled underneath the aircraft, it can cause the aircraft to have an uncommanded nose down attitude that's extremely difficult to recover from. And just as an example, these are the wires from the ground from inside the running aircraft, and you can see against the contrast of the sky, wires are very, very easy to see. These are the same wires pictured in that picture from altitude when we were doing a high recon of that landing zone from about 1,000 feet AGL above ground. So there are wires running along this driveway here, and there are wires running along this roadway here, and they're essentially impossible to see. In fact, there's 4 or 5 separate wires here and 3 here. Like I mentioned a little bit, foreign object on deck, or we call it FOD, these are items that are light enough to become airborne into the rotor wash. Things like plastic bags, like construction netting, like we saw with Metro Life Flight, leaves and other debris, rugs, construction cones and barrels. Anything that is light enough to be thrown can be thrown by the rotor wash. One thing that people often forget is if we're landing right next to a parking lot, I guarantee if there's a pickup truck in that parking lot near the landing zone, it is going to have loose items in the bed of that truck that are going to become airborne and either damage the truck, damage cars around it, or worse yet, damage the aircraft. When we ask you to kind of police FOD around that area and make sure the landing zone is truly safe from these lightweight items, make sure you're walking through the landing zone itself to identify if there's things that you didn't see from the road. Obstacles that need to be identified for us include light poles, signs, curbs, railings, fences, stumps, essentially anything that causes an uneven surface or anything that protrudes up from the ground that we can hit with the aircraft or get hung up on. Signs are kind of a common tail rotor strike risk. We may come into the landing zone and think that we're good and do a pedal turn and have a tail rotor clip a sign. Thankfully, our program has not had issues with that, but that has been a program nationally. There's a program out of Danville, Pennsylvania, that actually landed on a small signpost, and it actually penetrated the belly of the aircraft. So these things can happen. I already spoke a little bit about wind direction. It's best to land into the wind. It gives us more lift and requires less power of the aircraft. Easiest way to determine which way the wind is blowing is look at flags in the area. That's going to be the easiest way. This time of year with people that have chimneys going and you see smoke or steam, identify which way that stuff is blowing, and we're going to be coming into that wind. And if there's other blowing debris. If you're calling us for a hazmat scene, we will not land at the site of contamination. We don't want to risk getting the aircraft contaminated. And not only that, if it's a hazmat scene involving a flammable substance, we have essentially 2 blowtorches sitting on top of that aircraft that are emitting 700 degrees Celsius jet exhaust. And there is a very, very intense flame in the burner can of each jet engine. So if there's a explosive concentration of flammable vapor in and around that scene, we're going to have a really bad day along with everybody on the ground. So we prefer to land the aircraft at least 1 mile away and upwind. All patients must be decontaminated prior to entering the aircraft. We are kind of limited with the things that we can use to decontaminate the inside of an aircraft because of the components the aircraft is made out of. Aircraft are made out of composite, carbon fiber, aluminum, Lexan. There's a lot of things that aren't too forgiving to very caustic decontamination agents, or worse yet, caustic contaminants. And actually, aircraft aluminum is so brittle that if we have a patient bleed in the aircraft and it gets underneath the floor of the aircraft because the patient is exsanguinating, we actually have to tear down the aircraft to the airframe because blood is corrosive to aircraft aluminum. So we prefer not to have those things in the aircraft like caustic contaminants because it'll damage the aircraft. We also will not make patient contact until the patient is decontaminated. Our staff all have hazmat awareness. We are not hazmat technicians or hazmat operations specialists. We cannot go in hazmat PPE into a warm or hot zone. Our crews are not trained or equipped to do that. So we are cold zone responders when it comes to hazmat incidents, and as such, all patients should be decontaminated in the warm zone as they progress to the cold zone. Drones are especially concerning right now, especially, right after Christmas season and everybody got a drone for Christmas and they're out there flying it thinking that there's no rules and they're just doing whatever they want. They're really, really problematic for us, even in rural West Virginia. If you, if you're a hobbyist and you went to Best Buy and got yourself a drone, you actually have to register your drone with the FAA. It asks for your serial number, who you are. I think it's like a $5 registration. And it actually requires that the approval number that you get from the FAA be posted somewhere on the drone. So if you crash your drone into the front lawn of the White House, they know whose drone that is. I guarantee you, even if you don't have that posted, they'll figure it out. If you're a non-hobbyist, so you are using a drone for commercial gain, so you are shooting video for a real estate agent, you're getting paid for your drone footage from a news agency or something like that, you actually have to have a remote pilot license under Part 107. So if you're on this call and you have a drone and you've been paid for your drone footage and you don't have a unmanned pilot's license, you're kind of in some hot water if the FAA were to find out about that. It's usually about a $25,000 fine and potential jail time. So I would definitely look at getting your Part 107 license. It's literally just to test. It's easy. It's a lot easier than paying a huge fine and going to jail. Drone regulations in the United States make it illegal to fly a drone higher than 400 feet in most circumstances, have the drone out of the operator's sight, fly within 5 miles of an airport, hospital, heliport, correctional facility, or military base, and interfere with the operation of emergency response aircraft. If you are setting up a helicopter landing zone and we're not there yet, and you recognize that there is a drone flying around kind of, doing essentially the high-tech version of rubbernecking that we're used to from drivers passing crashes on the interstate, you need to immediately notify local law enforcement to have them find the drone operator and have them land that drone. And you also need to immediately have somebody notify the dispatch center for that air medical agency that's coming, so we know not to make an approach into that landing zone until the drone is secured. If you cannot get the drone operator to land or you can't find them, we need to move that landing zone away from that drone, because if we strike a 4 or 5 pound drone with the rotor blades of the aircraft, it's going to cause a significant amount of damage and could potentially be fatal to the crew. So we will not land if there is a drone in operation in and around that landing zone. At night, we will be using night vision goggles. That's actually a requirement for a lot of accreditation and federal aviation regulations, that we do aided flights at night, aided through the use of night vision goggles. We definitely appreciate you not shining bright lights directly at the aircraft when we're wearing night vision. That's not exactly the best thing in the world. And after we identify the landing zone and we've identified the hazards, like I mentioned, you're probably going to be asked to turn off your scene lights, to turn off your headlights, to turn off all your flashing LEDs, because those will kind of bleach out the NVGs and make it harder to see what's on the ground. Night vision works great at amplifying ambient light, and if there's a lot of ambient light, it's going to amplify that, and it makes it harder to see. Radio communication with the ground is probably going to be required for night landings. I can't speak for other programs. It's required for ours. So you need to identify some sort of radio frequency in order to be able to talk to the flight crew and identify the hazards in that landing zone and kind of give them a brief of what to expect. The other nighttime considerations, we're having an increase issue with laser strikes. Targeting an aircraft with the laser is a federal crime. It's a federal aviation violation. So if you decide one day to buy a laser pointer and shine it at aircraft and you get convicted, you will be going to federal prison over that. It has been an issue within our program. We have actually been targeted by a few gun sight lasers. We know because it's pretty hard to hold a laser that steady unless it's mounted on a bipod or something. So that's a little alarming. If you see a laser striking an aircraft, notify local law enforcement, notify the crew that there's a laser in the area. Our response when we get targeted by a laser is to immediately turn the tail towards the source of the laser beam, so it's harder to strike the cockpit, and we're going to fly in the exact opposite direction of that laser into an area to where they can't target us. It's usually going to be a few miles away and at lower altitude to where they don't have direct line of sight of our aircraft. And this has been an issue the last few years. If you see those Christmas light displays that are the 1,000 points of laser light on a house, those are miniature laser beams. Those laser beams that are not striking the house are going past the house straight up into the air. Those are not exactly pleasant under night vision. So if you do have those and you do use those every year for your Christmas display, make sure they're tilted more down towards the ground than up towards the sky, especially if you live near an airport or a hospital. Your local air medical crews and all your pilots will thank you for that. So just to give an example of what we see with night vision, so this is just an unaided photo off of one of our base sites, just looking at a tree line. So there's really not too much definition. You can kind of see stuff in the foreground that's illuminated, and that's about it. That's the same scene with NVGs. And you can start to see that there's wires present. There's a pole that you couldn't even see. There's more trees. So the night vision really kind of gives us some better definition of what we're dealing with. However, when you shine bright lights at night vision goggles, it tends to do that. It will bleach out everything. Night vision goggles have something called automatic brightness control. So it's not like on Step Brothers when somebody turns on the light, your retinas get scarred because the night vision burns them away. The night vision has built-in protection to dim the display of the night vision goggles. But as they dim, like you saw, you lose all the background definition because it's accommodating that extremely bright light. When you're communicating with the aircraft, you want to designate a ground contact. This is the person that's going to speak to the aircraft via radio. We need them to speak clearly and slowly to where they're actually going to be understood. I know there's usually a lot of excitement if an aircraft gets involved. I completely understand. I flew on one for years and I felt the same excitement every time I flew. But you need to be able to communicate clearly. We're not going to be able to understand you if you're holding the microphone right to your mouth or speaking extremely quickly. You need to speak slowly, clearly, in 2 to 3 sentence blocks, and then give us a chance to make sure that we've actually copied that and to ask questions. And we want you to accurately communicate the landing zone information to the flight crew. It is a little difficult trying to find a radio frequency if you don't commonly call for aircraft. There are designated frequencies that aeromedical operators use. If you don't know what they are, contact the aeromedical provider that you most commonly use, whether it's Metro Life Flight, whether it's UH, whether it's Stat Medevac, and they'll gladly tell you what their preferred frequency is. We can program our radios with specific frequencies on the fly, so to speak, but we're kind of limited with what we can do. There's certain frequencies that we cannot program, and we definitely prefer you, we prefer you don't use your main dispatch frequency. If there's going to be a lot of chatter on that frequency, it's going to interfere with our communication to you and your communication to us. So ideally, we want to identify a frequency that we're just going to be on by ourselves. Because if somebody's trying to give a report to a hospital on the same frequency that we're trying to talk to you on, they're essentially blocking us out, and it's just going to delay the whole process. So find a dedicated frequency. In West Virginia, we actually have specific ground-to-air and air-to-ground radio frequencies that are just for helicopter operations for EMS. They're called Helo 1 and Helo 2. Those are UHF frequencies, and we actually have 2 others that are in the VHF band. And those are specifically reserved for helicopter scene operations. So they're really not cluttered up with a bunch of other radio traffic. So it's kind of nice that we have those set up statewide. Most EMS providers and field agencies in the state know when they call dispatch to request an aircraft, they're going to tell us to use either Helo 1 or Helo 2 and tell us who we're talking to. If you have to converse amongst other units, please do it on your own dispatch or talk around frequency. Don't do it on the air to ground frequency because we may be trying to relay something. When you're communicating with the aircraft, don't use your position on the ground unless you have a reference for us being able to easily find you. Ideally, we want you to refer to where you are in relation to the aircraft. That's going to make it easier for us to find you. The nose of the aircraft being 12 o'clock, the tail of the aircraft being 6. So if we're flying at you and you can see the left side of the aircraft because we're flying past you and all you see is us broadside and you see the left side of the aircraft, you could just say, hey, we're out your 9 o'clock, and we're instantly going to know to look to our left side of the aircraft for you. You can use compass directions, but some people are challenged from the Magellan standpoint and have issues with cardinal directions. So honestly, using the aircraft clock position is the easiest. Just remember the nose of the aircraft is 12 o'clock. Now, what you're going to see here, it may be a little difficult to hear. I have the audio shared, but naturally this is combining audio from inside of an aircraft with our radio system, you're going to hear two examples of landing zone briefs. And the reason that I'm putting this in here is some EMS providers have never done this because they've relied on the fire department to do it, but there may come a day that you have to do this for yourself, or you have to assist another EMS crew by helping set up a landing zone. So it's just a good skill to have in your back pocket and hear kind of examples of how to communicate this. The first example here is what not to do. You're going to hear some things that you're like, why would you even say that? And then you're going to see an example of what you should do. So first, we're going to do the example of what you should not say on the radio when you're trying to talk to an aircraft.
Okay, is that your north, south, east, or west?
Well, we still have you in Side LF3. You're still out to our left. We're down by the church. You know where we landed a few years ago when we had the bulldozer accident?
Engine 1, we've got you in sight. Can you give us an LZ description?
And just to give you a quick example of how difficult it is to see you from the air, this is the landing zone here, and that white speck is the ambulance. So when we say that we can't see you, we're not being particular and we're not trying to be difficult. Things are extremely difficult to see from the air when we're trying to fly around looking for you. Believe it or not, it is much easier to find you at night than it is during the day, because under night vision, the reflection of your flashing lights are extremely obvious, and we can see you from miles away at night under night vision goggles. During daytime hours, it's extremely difficult to see you. So this landing zone here is actually where we're going, and that's actually the ambulance, that little white speck.
You'll be landing in the grass beside the parking lot. We're making construction. There's some power lines, but it's not any way.
Okay, you got the power lines down there running along the driveway in the road there, Emily. I don't see any other obstruction.
Can you hurry up and land?
All right, we'll be making our approach. We'll be on the ground here in just a few minutes.
I'm keeping this playing for now to kind of give you an example of, like I mentioned with the issue with wires, you can kind of see a wire here. There are 4 or 5 power lines crossing this street here, and then there's also power lines paralleling that roadway. So kind of watch in that area to see how late it actually is before you see those lines. And I'm sure everybody can see the 1 right here, but just know there's another 3 to the right of it. So I'm going to move on for the sake of time to kind of the better description. So we can see what happened there. We didn't get a clear direction as to where the scene actually was. They didn't identify the wires. They didn't attempt to mark where the wires were to make it easier for us to find it. Didn't describe the landing area. Asked if we could hurry up and land. And I guarantee you, if an incident commander tells me that over the radio, we're going to have a very, very frank conversation when we get on the ground. There's a certain process that we have to go through as flight crew to make this safe, especially when we've never been to a landing zone and it's an improvised site. We want to make sure that we're not going to risk injury or death to us, and we don't want to cause injury or death to anybody on the ground. So we're going to do everything by the numbers and take our time to make sure we do it right. So I won't go through this here, but this is a little bit better description of that landing zone itself, and you'll kind of hear the difference in communication.
HealthNet 3, we can hear you to our north.
4160. Okay, we have you in sight. Can you give us an LZ description?
HealthNet 3, you get us on site. We are out to your 12 o'clock at the church, just to the west of Route 3.
Okay, are there any obstructions, or what kind of description of the LZ can you give us?
You'll be landing in the grass fields to the north of the church parking lot. There are wires running parallel to the road along the driveway and parallel to the house to the north. We have trucks parked under the power lines, correct?
Copy, wire locations go with your description.
And you can kind of see already that they have trucks parked underneath those wires, which makes it instantly that much easier to find those from the air. So we know that they said our trucks are parked underneath the wires. We know that where those trucks are parked is not a safe area for us to make a low approach. We need to maintain some altitude above that. So they just kind of go through a little bit better description here. You can see LZ's level, shortcut grass, wind direction, best approach. So it's a very thorough description, and those are the things that we want to hear from our ground crews. So that way we know what we're getting ourselves into once we get to that landing zone. When we talk about weather minimums, if there's one major point of contention that I hear from ground providers about air providers are things related to weather. They don't understand why a flight got turned down for weather when it was clear at the landing zone and there was no weather in their immediate area. But there's a lot more to just weather at the pickup site itself. We have to worry about weather at our base site, en route to the pickup point, from the pickup point to the destination. So there's a lot of different legs to the flight that we have to worry about. We conduct the majority of our flights using visual flight rules, which means we have to be able to see around us. So we have to have a certain distance between the clouds and the terrain, and that's called a ceiling. And we have to have a certain distance of forward visibility. So when we're looking at weather, we're looking at any areas of precipitation and ceiling and visibility. The weather minimums vary depending on what you're in. All of West Virginia is considered mountainous terrain according to the FAA, so our weather minimums are a little bit higher. So we have to have a little bit better weather than what you have to have in flatter terrain here in Ohio, just because of the very, very unforgiving terrain that we're dealing with. And similarly, at night, you have to have better weather at night than you do during the day, because with that lower illumination, it's going to be that much more difficult to see obstructions or obstacles if you're out in bad weather. And just an example, this is one of our base sites in Buchanan, West Virginia. If they were responding to this volunteer fire department, there is a mountain range between them and that fire department that is at 3,700 feet. So we would need, during the daytime, 800-foot ceilings. So we would need 4,500-foot ceilings because we need that 800-foot clearance, and 4,700 feet at night. So it's based off of the highest obstacle on our flight path. Now we can do instrument flight, and this is flight in weather conditions that are far less than that. We can actually fly in zero visibility, but we are on a flight plan that is filed with the FAA, and we're going to from an airport to another airport or to a hospital helipad that has an instrument approved approach into there. These are extremely strict flights that we conduct. They are done with higher fuel reserves, more alternate planning. These require usually about 20 minutes to plan before we can get off the ground. So we use instrument flights a lot for interfacility missions, but we don't traditionally use them for scene flights because the added delay of planning all of these things means you could probably be at a medical center before we get these things planned. And just to give you an example of what it looks like out of the front of the aircraft when you're truly in IFR conditions, this is me sitting in the co-pilot seat looking out of the front of the aircraft, and we are, let me move this thing here, we're at 4,500 feet above the ground, and you can't see anything past the front of the aircraft because we're in the middle of a cloud layer. So this is done in an extremely structured manner because if you don't, it can be extremely unsafe. We have to have very, very specific weather minimums to fly approaches at airports. So if you're facilitating a patient transfer with an aircraft that's coming IFR, chances are you're going to be going to an airport or a hospital helipad that has an approved approach, and it's going to be an interfacility mission. You can do rendezvous for us at a hospital helipad. It is permissible. We have guidelines in West Virginia for how you're supposed to do that because there is always the question of if you come on hospital property with a patient, at what point does the hospital's obligation to the patient begin under EMTALA? And that gets really dicey when the only access to the hospital helipad is through the hospital. If the helipad is adjacent to the hospital on hospital property, in West Virginia, you can sign a memorandum of understanding with the hospital that sets forth the guidelines on how that should be arranged. Usually there's a certain time period that if the helicopter's not there within a certain amount of minutes after you've arrived at that helipad, then you're to proceed into the hospital so they can evaluate that patient. If the only access to that hospital helipad means you have to go through the hospital, then that means EMTALA is going to be an issue for you, and the hospital is going to have to evaluate that patient before they're flown. And like it mentions here, I mentioned this before, we don't require charged fire hoses for landing zones. The reason being, we don't often crash arriving and departing at the landing zone. It's usually on approach a little ways away from the landing zone or departing a few miles away, because that's when we're at extremely low altitude and low airspeed. If we have an emergency and we're departing that landing zone, we're probably not going to come right back into the confined landing zone we just left. We're going to try to fly out of it to a different area. And if you have charged fire hoses, that's going to delay your response to help us, so we don't require them. After we land, don't approach the running aircraft without permission from the flight crew. That's an easy way for one of us to do an open field tackle on you to make sure that you don't go into the nice spinny things that will put a permanent part in your hair. Follow the flight crew instructions, secure all loose clothing. Everybody forgets about their hats. Don't be offended if you're going to help a flight crew load a patient and they just grab your hat off your head and throw it into the ambulance. They're doing that for everybody's benefit because they don't want it to fly off into the rotor system. And they also don't want you to chase your hat straight into the tail rotor. Stay clear of the tail. As we're loading a patient, there will be a tail guard usually that kind of has their arms out protecting the tail of the aircraft and making sure nobody goes back there. And please allow the flight crew to operate all the doors and latches. If you go Mongo smash on a door latch and snap it off, that aircraft cannot legally depart that location until a mechanic comes out and repairs it. So we're going to have to transport that patient by ground. So allow the flight crew to operate all of the doors and latches. Do not approach an aircraft from the rear of the aircraft. That's where that giant spinny problematic thing is back there. Even on aircraft like the EC-135 that have the enclosed tail rotor, it's still extremely hazardous with some of the winds back there to be at the rear of the aircraft. A good point to remember is on our aircraft, most of the EC-135s have these horizontal stabilizers back there. Don't be behind the horizontal stabilizer. That's a bad thing. Always approach from the sides of the aircraft because on our 135s and 145s, the rotor system is slanted slightly forward. So the rotors are actually going to be lower to the ground in front of the aircraft. The other consideration when you're approaching the aircraft is to always make sure that the pilot is aware or the flight crew has approved your approach to the aircraft, and never approach from an uphill side towards the aircraft because the aircraft is going to be a lot lower. The rotor tips are going to be lower to the ground on that uphill portion. So always approach if there's a slope from the downhill side, so that gives you the best clearance to the rotor system. Hot loading, we will do this on most of our scene flights. We will definitely do this if we're on a major roadway. Helicopters like to throw caution lights at the least inopportune times, just like when we're shut down on a roadway and try to start up and we get a caution light and have to sit there. The state police really don't take too kindly to us parking our paperweight in the middle of Interstate 11 or 680 or 711, so we try not to shut down on major roadways. The other issue with hot loading that we'll use it for is fuel burn. So if the patient weighs a lot more than expected, and we're going to be close to our maximum gross takeoff weight, a lot of times our pilot will drop us off on the scene and actually depart, because it's a lot safer for our pilot to be flying around than it is to be sitting on the ground just running, because anybody can approach the aircraft. It's really hard to approach the aircraft when it's flying. So if we have to do fuel burn, the fuel burns a lot quicker when you're flying than it does when you're sitting on the ground. So if you call for an aircraft and they immediately take back off, that's probably what they're doing. And we also use it for rapid on-scene time. It only takes a few minutes to start our aircraft and to shut them down, but we will use it to expedite our on-scene time. When we're doing hot loading and leaving the aircraft running on scene, we will designate at least one person on that scene to be a tail rotor guard to make sure that nobody comes up from the rear of the aircraft, because that's a blind spot for the pilot. They will not know if somebody's approaching from behind. So we're going to have somebody at least 50 feet away from the aircraft watching the rear of the aircraft just to make sure that nobody comes up from behind. Please follow all flight crew commands. Don't jump for joy underneath the rotor arc because you may come up a little bit shorter after that. So don't reach anything above your head. Don't hold anything above your head. So if you're holding an IV bag, don't be the human IV pole that holds it at arm's length above their head. You may not like what comes back. So just keep it at head level or below. Enter and exit in safe zones that we talked about in full view of the flight crew or the pilot. If you have hearing and eye protection, by all means wear it. Under the rotor arc is an area that has about 110 decibels of noise at the engine exhaust. So it's extremely loud. It can damage your hearing. That's why all of us wear our flight helmets in the back and when we're operating around an aircraft, because it has integrated audio protection and it has integrated eye protection with our visors. In the sake of time, I'm not going to show the hot loading videos. If for whatever reason we have a really bad day and you need to perform a rescue on us because we had an issue at the landing zone or adjacent to it, it's kind of important to know what the aircraft is made out of, because some areas are going to be easier to ingress and egress than others. The majority of our aircraft is actually made up of a carbon fiber composite, so it's extremely easy to get into those areas. And the bulk of the strength is in the floor and the rear wall. Those are the things that are going to hold up the most because they're the load-bearing surfaces. The rear wall is reinforced because that's where the tail attaches to the main fuselage of the aircraft. And the floor is the most reinforced because that's what takes the entire load of the aircraft when it lands. The windscreen is made out of essentially plexiglass. So if the aircraft is damaged because of a hard landing and crashed and you can't get in the door, don't feel bad about breaking the windscreen. Those are easy to replace. Crew members are not. So do what you have to do to get us out. Metal, there is a lot of aircraft aluminum in structural components, and the rest of the body is usually made up of fiberglass or carbon fiber. So if you have to do extrication, it can be accomplished with a lot of power tools, such as reciprocating saws. You traditionally don't need cutters and spreaders. These are things that are extremely easy to get through. You could cut the composite material, rip or saw it. If the impact is significant enough, there's going to be little need for extrication. If you're doing fire suppression, it should be done with foam. Most of our aircraft are carrying in excess of 100 gallons of Jet A. So there is a significant amount of jet fuel on board. So we don't want to use water and spread that everywhere. We want to use aircraft foam. And if for whatever reason you come up to the aircraft after a hard landing and the engines are still running, there's a very, very easy way to shut it down on aircraft that are so equipped. On the top panel of the dashboard of the aircraft, there are two switches. These are emergency shutdown switches. If you flip up these red guards, and it's going to require some force because they're wired in place, so that way they don't get accidentally lifted. Flip up that guard. That's the shutdown for engine 1 when you push the button. Flip up that guard, push the button. That's the shutdown for engine number 2. Only do that if the flight crew is incapacitated or otherwise unable to do that. It will not damage the aircraft to any extent, but if the pilot is fully conscious and able to manage everything, you don't want to be pressing buttons in the cockpit if he doesn't know what you're doing. So that is an easy way to shut down the aircraft if the flight crew is incapacitated. Crew rescue, the front door of the aircraft in the 135s and 145s and 130s kind of swings outward. There is no designated emergency exit there, so you're just going to have to pry the door open. The rear door to the patient compartment in the 135s and 145s, they have emergency exits in the window, and there's instructions on the door. And then the door is actually also on sliders and is kind of scarily easily removed. And if the crew's still belted in, it's just like a 4-point racing harness. You just twist the face of this seatbelt buckle and it'll come unlatched. If you have to get the patient out, there's latches at the back of the aircraft. The 135s have 2 latches, the 145s have 3. Once you undo those latches, you'll be able to open the rear doors. Just know that clearance is going to be an issue. If the patient is sitting up in a 135 and you try to rip them out of the aircraft, you're probably going to smack their face against the rear wall of the aircraft, so please be cognizant of that. There is a latch underneath the cot that releases the cot from the aircraft, and you can just pull the stretcher out. These are 1-person stretchers, so as you back the cot away from the aircraft, the wheels will fall and lock into place. And I won't go over the 130. Any questions on that before I talk about helicopter utilization in 15 minutes? All right, we'll breeze through this as best I can to try to get us out as close to 9 o'clock as we can. So we talked about how to safely operate with a helicopter on scene, but now we're going to talk about why you would even call one in the first place, because there's a lot of confusion on when you should, when you shouldn't. One person says one thing, one person says another. So we're going to talk about the clinical need for helicopter air ambulance utilization. We're going to talk about risk benefit for the patient, how to integrate helicopter assets into your EMS systems to make it more efficient. And we're going to talk about quality assurance after you call a helicopter to make sure it was truly the right decision for that patient in that situation. Everything in this document is not just what I'm saying. This is the most evidence-based background for it that we have. This was based on a joint position statement and resource document that the National Association of EMS Physicians, the American College of Emergency Physicians, and the Air Medical Physicians Association put out in October of 2021. This document originally came out in 2013, but they updated it in October of last year based on the emerging evidence regarding helicopter utilization. So what they have identified is they really want us to focus on our use of helicopters on patient-centered goals. We need to really think about calling air assets and aircraft and helicopter EMS crews to do something tangible for that patient, not just because. It used to be that we called aircraft based on mechanism of injury, and that is partly due in part to the trauma triage guidelines that were in place at those times. There are a lot of trauma teams activated, and I'm sure everybody on this call that's been doing it for more than a few years knows how many unnecessary trauma teams had been activated over the years based on mechanism of injury alone, with no outward signs of injury and no appreciable time-sensitive thing going on with the patient. We're starting to pivot away from mechanism alone and really starting to think as clinicians on this and not just technicians, and focus on what are we trying to accomplish with this patient, what are we seeing with the patient, and what is our outcome goal. So the patient-centered goals that they have identified that patients can benefit from helicopter utilization is if they need initiation or continuation of locally unavailable advanced or specialty care, so certain interventions, expedited delivery to definitive care for time-sensitive interventions such as STEMIs and strokes, and extrication from physically remote or otherwise inaccessible locations that limit timely access to necessary care. So that's one component of these considerations for air ambulance utilization. So those are the clinical criteria that we really want to think about when we're starting to consider flying a patient out. But that also needs to be balanced with identification of the risk of putting a patient in an aircraft and having a flight crew come out, and the safety considerations for everybody involved. And the other thing we want to look at, like I said, is, and it's another big consideration of using air assets, we want to make sure that they're integrated into our systems in an efficient manner. Because if we only call an aircraft once a year and it takes us 45 minutes to figure out how to get an aircraft to our location because we've never figured that out, we're not doing the patient any good, because chances are we could have been at a hospital by then. And if they truly needed a time-sensitive intervention, then chances are we've blown through that window. And then the last consideration is the quality assurance piece. So under clinical considerations, these are some of the time-sensitive or intervention-dependent patients that we traditionally think of when we think about flying, trauma being one of them. There are definite perks to flying trauma patients when you're talking about hypovolemic hemorrhagic shock. When we're thinking about trauma resuscitation in the field, it has long been done with normal saline. There's some programs that have switched to plasmolite, which is another crystalloid that's far more pH neutral than normal saline. But even with that, we're still causing acidosis, we're still causing hypothermia, we're still causing dilutional coagulopathies. So we're essentially still causing that lethal trauma triad. And the worst part is the patient's losing oxygen carrying capacity of their blood, and we're not able to replace it. So a lot of air medical providers have recognized this, and a lot of this data has come from the military, and a lot of us are carrying blood on our aircraft. We, for example, are carrying 2 units of packed red blood cells and 2 units of fresh, never frozen plasma. And we're actually getting ready to kick off a joint study with the DoD and WVU on carrying whole blood on our aircraft. That should be hopefully sometime this year. So that's definitely a big consideration. If this patient has lost a significant amount of their circulating blood volume, and there's a significant transport time to a trauma center, then you should probably consider Aeromedical, because they have the ability to do some volume resuscitation in the field that's going to be beneficial for the patient and not detrimental. We carry inline blood warmers in addition to our blood, so that way we're not causing hypothermia, because blood is supposed to be stored at 4 degrees Celsius, which is pretty cold. Naturally, you don't want to give cold blood to a patient, so we do carry inline warmers. Pivoting over to medical, these are more of the time-sensitive things that we need to think about. STEMI and neurological stuff. Sure, Larry may talk about this and kind of hit on this at the end with the recent legislation in Ohio about needing to transport stroke patients to primary or comprehensive stroke centers if it's within a certain time window and available to you. Naturally, with neurological emergencies, we can fly the patient to a comprehensive stroke center if it's a known large vessel occlusion, and kind of cut out the primary stroke center in the mix and get them to that tertiary center. OB and neonatal, the only thing I'll warn you with OB is if it's an impending or imminent delivery, don't call an aircraft because it's not a very friendly environment to deliver a baby in the back of a helicopter. It's pretty cramped. Access to the patient is limited below their waist. So we would rather not deliver. And in fact, if the patient is having a precipitous delivery, our flight crews will not fly that patient until we deliver that newborn. And then we will arrange separate transport for mom and baby. And then there's other med surg things like if there's airway compromise due to like an ACE inhibitor, induced angioedema, severe anaphylaxis, severe respiratory distress, or there's some other need for an advanced intervention, that's another consideration. I mentioned this here before we move on much further. I mentioned blood products and trauma. Last month was National Blood Donor Month. Blood supplies are extremely limited right now. A lot of trauma centers are okay on blood products right now, but some of the smaller hospitals are suffering. So if you have donated blood before, thank you. If you have not, I encourage you to consider it. And if you haven't donated in a while, please reach out to the Red Cross and consider donating blood if you can, because that's crucial for us. I know I used to donate blood all the time when I was flying, and it was kind of nice to know that my unit of blood may even be stocked on one of our aircraft as never frozen plasma because I'm AB positive, and helping to potentially have a good outcome with a patient. So if you haven't donated blood in a while, please consider. Some of the other considerations when we think about calling aeromedical, this used to be our bread and butter, but we're trying to get away from just instantly intubating patients anymore and going to more non-invasive ventilatory modes just because the patients tend to have a better outcome. But ultimately, some patients are going to need aggressive airway intervention regardless. We have a little bit more tools available to us through drug-assisted airway management, or DAM as it's called. We traditionally have referred to that as RSI, or rapid sequence intubation, or drug-assisted intubation. I'm not a big fan of the RSI moniker just because there's nothing rapid about an RSI procedure, and if you're doing it in a rapid fashion, it's not going to end well. Flight crews have extensive training in surgical airways, so if there's a foreign body airway obstruction, laryngeal trauma, or something else that is making the intubation almost impossible, and you're kind of in a can't intubate, can't ventilate type situation, that is something that a flight crew may be beneficial. The other thing beneficial for us is if we have a patient that does get intubated in the field and it's an extensive transport to definitive care, all of the aircraft are equipped with ventilators, so it's a lot safer for the patient to hook them up to a ventilator than it is to bag them the entire way. If you have burn patients, naturally getting a burn patient to a burn center as soon as possible, especially if there's airway burns involved, is extremely important. The other thing that we can do is if there's circumferential burns to chest or extremities, our flight crews are trained and equipped under protocol to do eschorotomies or fasciotomies if there's a impaired ventilation or compartment syndrome. And the other thing that we do have on our aircraft as well that's kind of a clinical aid is point of care ultrasound. So these are actually the ultrasound devices that we carry on our aircraft. They just hook up to an iPhone, and it's a butterfly ultrasound device. We use those for modified FAST exams on trauma patients in the field. We also do this for vascular access, and we also do this as ultrasound guidance for pericardiocentesis, which we do in the field on trauma arrests. That document I mentioned at the beginning, this image here was in that position statement, and this is what these three physician agencies kind of agreed upon. There's a lot of discussion on, well, I flew that patient because they're time sensitive. So we kind of moved away from clinical-based criteria, and now we're talking about time-based criteria. And they really wanted to define where is the benefit zone for favoring air transport versus ground transport. And what they found is right around 35 miles of ground transport, that's when it really starts to favor air medical dispatch. Shorter transports than that tend to favor ground EMS. And there's a few different reasons for that. So it's kind of a variable benefit zone. So don't please do not take away from this lecture that my transport is 34 miles and Justin said never to call an aircraft. That's not what I'm saying. What I'm saying is shorter transport distances tend to favor ground transport just because there's a certain amount of time it takes to get an aircraft in the air, and you can be making progress towards that hospital. Further distances naturally are going to have a higher benefit towards air medical because we can fly faster than being on the ground. And then the last criteria that we talked about earlier that I'm going to expand upon is remote access or difficult access to a patient. We in West Virginia have the Hatfield and McCoy Trail system, which is a few hundred miles of ATV trails through extremely remote rural areas that take hours to get back to by ATV. So when people are injured on these trail systems, usually the only way to safely get them out of there in a reasonable amount of time and in a comfortable amount of time if they're severely injured is by air assets. And we often get involved in some pretty remote landing zones where extrication of the patient is only accomplished via air assets. And this was the picture Matt commented on a few weeks ago. This was another incident that we had on the Gauley River. So when I say limited access to the patient, I mean it. Just because the patient's entrapped in a vehicle does not mean that is limited access to the patient when you're standing on an interstate. As soon as you get that patient out, you're able to get to the trauma center fairly quickly. But if you're in these kind of situations, you can very easily see how air medical is probably the only way you're getting that patient out of there. Some other considerations for air medical are mass casualty incidents or special security incidents. We do training with the West Virginia State Police, West Virginia Department of Corrections, and ATF every single year on prison riot situations because we have a regional jail system throughout the state. So if there's a law enforcement officer that were to get injured in a prison riot situation, we have training with them to kind of access a hotter than usual LZ, get them out of there quickly and out of that environment. And it's not because they can't get out of there by ambulance. It's just a lot safer to get them out of there quickly and let the other officers on scene focus on what they need to focus on. And the reason that I talked about in that one image where transport distances shorter than 35 miles tend to favor ground transport, there's a lot of risk and safety considerations that we need to go through as flight crew. I already mentioned in the previous lecture about doing a weather check. We have to do a pre-flight walk around. We have to do a pre-flight risk assessment. Startup procedures take time. And we also have this thing of 3 to go, 1 to know. And what I mean by that is it takes the agreement of all 3 flight crew members to accept a mission. But it only takes 1 flight crew member saying, no, I don't feel comfortable with this, to immediately abort the mission. So if you're waiting on a landing zone for us 15 miles from a hospital, we make it 12 minutes en route and turn around because we felt uncomfortable with the weather and the way it's developing, and turn around and head home, you've wasted that time sitting at the landing zone when you could have been en route to the hospital. So that's why I'm saying some of those shorter transport distances benefit the patients more going by ground. And this is one of the things, if you're thinking of hopping off right at 9, please let me finish this one slide, because if there's nothing else that you take away from this lecture, I hope it's this slide. This helicopter crash is very close to our program's heart and kind of near and dear to us. This was a survival flight helicopter that crashed in Ohio, January 2 years ago. There was a small hospital on the Ohio-West Virginia border that had called for helicopter transport of a patient to Columbus. They called MedFlight of Ohio. MedFlight of Ohio immediately declined the flight due to weather. Then they called our program. Our dispatch center relayed it to the crew, and the pilot said, I'm going to have to do a pretty intense weather check because the weather's not great. Let me do a weather check and call you back. So they called the facility, our dispatch center did, and said, hey, our pilot's doing a weather check. We'll call back in a few minutes and let you know. In the meantime, they got impatient and called a third flight program. Now, mind you, they had never told any of the flight programs that anybody else turned this flight down due to weather. The third flight program immediately accepted the flight without doing a weather check and crashed about 10 miles from the hospital, killing all 3 occupants on board. We were involved in the NTSB depositions on this because our program turned down that flight. About 5 minutes after this program accepted the flight, we called the hospital back and said, hey, we can't do it for weather. And that was never relayed to the program that accepted, and this was the end result. They got disoriented in a snow squall, came out of the clouds essentially upside down, and crashed in a wooded area outside of Zaleski, Ohio. So when I tell you that this is near and dear to us, that process that they went through is called helicopter shopping. It is strongly condoned against by the FAA, the NTSB, CAMES, which is our accreditation board. All of these agencies have come out and spoke vehemently against this practice. So if you are a ground provider and you get told no by a flight agency because of weather, if you are going to call another flight agency, make sure you're calling that other flight agency, A, for a specific reason, because you're trying to maybe fly the patient in a different direction. And B, if you do, make sure it is relayed to that other program that somebody else turned this flight down. Don't spend all day calling flight programs until somebody accepts, because ultimately there's going to be a program with a less than stellar safety record. And I'm not saying anything to disparage this program. The NTSB report on this program was 150 pages long, and they identified numerous safety deficiencies. But ultimately, you may be calling just enough to get 3 funerals arranged. So if you get told no for weather, just please take that for what it's worth and do what you have to do to arrange alternative transport for your patient. The other things that we have to consider when it comes to flying patients are things like patient combativeness. If a patient is truly combative and violent, it's much easier to manage that patient in the back of an ambulance with law enforcement than it is in an aircraft at 3,000 feet with only 2 people. If the patient is truly combative, we are going to follow our chemical restraint process to make sure that the patient's rendered safe before we put them in the aircraft. All aircraft have patient weight and or girth requirements that the patients have to be below. In the EC-135, there's a narrow passageway at the rear of the aircraft that patients have to pass through. We call it the tunnel. If the patient is too wide or too tall off the cot, so they're too round, essentially, they will not fit through that tunnel. So we may get on scene and have to arrange a different type of aircraft. And I already mentioned patient contamination. Kind of wrapping up here. I know it's a little past 9. I'm going to try to finish up. There's some economic considerations for the patient as well. Please don't be calling aircraft because it's the cool thing to do, because you're going to burden that patient with an enormous bill. So if they don't need flown to a medical center, then by all means take them by ground. That bill is going to be a lot easier to pay. And the reason that these bills are so expensive is our helicopter costs about $7 million. Our 135s cost about 6.5, and our 130s cost about 5. We have, including spare aircraft in our system, 11 aircraft. So we have tens of millions of dollars of aircraft. We burn through almost $500 per flight hour of jet fuel. The maintenance costs about $1,200 per flight hour. Medical equipment alone, not including medications, is about $100,000. Some of our medications, like sodium nitroprusside, cost about $2,000 a vial, and we carry multiple vials of it. So it's very, very expensive and costly to adequately equip, staff, and maintain a high-performance air medical company. So there's a huge financial impact to the patients. I understand that we are more comfortable with over triage versus under triage. We would rather fly a few patients that don't need it than miss one that does. But we need to carefully evaluate our over triage through some quality assurance. As you integrate air medical into your system's response, know the local capabilities of your air medical providers. So know what capabilities Stat Medevac and Allegheny Life Flight and UH Medevac and Metro Life Flight have. So make an informed decision on who you're going to call. Understand where they're going to take these patients to, because that's going to influence who you call. Make sure your local providers are getting involved with specific LZ training with the companies that are going to be responding. If you're going to use a hospital landing zone, make sure there's agreements in place so everybody knows what's supposed to happen. And the last bullet point on here, authorized requesters, identify through your policies and procedures who can actually call an aircraft. And then after you do a flight and fly a patient out, you need to review this from a QA standpoint to identify opportunities for improvement. Naturally, if the patient gets discharged within 24 hours of arriving at the hospital, that probably was not an appropriate flight, and we probably need to consider why we flew that patient. Likewise, if there were no time-sensitive interventions performed at the hospital or no critical care level interventions performed en route by the flight crew, then you definitely want to look at that closely to kind of better the process next time to make sure you're not flying patients unnecessarily. You also want to review when helicopter air ambulances are activated by BLS crews and they never requested a medic. If it's bad enough that they need to request a helicopter, they should also be requesting ALS to come help out and have a more advanced provider look at that patient to see if the patient truly needs flown or if it's within the realm of an ALS provider. So to kind of finish up, we're not too late over. Make sure air ambulances are coordinated properly. They're based on patient need and sound medical decision-making, not based off a mechanism of injury, not based off of, I don't want to drive to that hospital. There needs to be a sound reason for calling an aircraft. And you also need to carefully consider safety and risk for the patient, ground EMS, and the helicopter crews. After you fly patients, like I said, review it carefully to make sure it was appropriate. And ultimately, the influence on whether or not we call aircraft for patient transports should be based on the outcome we're trying to get to with the patient. So whether it's a time-sensitive condition or a critical intervention, we really need to be outcome focused. And that is all I had. Does anybody have any questions?
Justin, it's Ralph.
Hey, Ralph.
Hey, I had a question about that wreck that you were showing us. And maybe you covered it, but did the FAA like hand out any punishments, or who would do that? Is there a separate board for like EMS to punish the requesting facility, or how does that go? And also, were there any like civil suits involved with that?
So that's actually interesting. So the NTSB is kind of like an advisory group. They advise the FAA on what they think should happen. So the reason that the NTSB is set up the way they are is they investigate, but they're not a regulatory agency and they don't have the ability to punish anybody. So they make recommendations to the FAA to say, this is the deficiencies that we identified and this is what we think you should do. But it's ultimately up to the FAA to implement that stuff. They identified a bunch of deficiencies with this program, and they also chastised the FAA because the last time the FAA investigated this program, because they've been investigated multiple times, the investigator assigned to that investigation for this helicopter air ambulance program was a fixed-wing pilot with no helicopter experience and had no EMS experience. So the NTSB really identified the FAA as a deficiency and said, you need to be assigning appropriate people to investigate these programs. There's a very tenuous relationship between the NTSB and the FAA specific to air ambulances. It took them almost 15 years for the FAA to take up the NTSB recommendations from 2008 and make them into legislation. So there is a civil suit right now against the company. I personally was involved with a trade organization that went to Survival Flight and investigated that program from a private standpoint and came up with recommendations. Once we started making some very difficult recommendations, we had the door slammed in our face and haven't heard much from them since. So it's still, the program's still in existence. They're going to pay out a huge civil settlement for the wrongful deaths of these crew members. But ultimately, that program's still going to be functioning. And that's a big area of frustration for the high-performing programs because these other programs are allowed to exist.
Thank you. Next question, kind of following up, during the process, did they shut the whole program down completely? a word, like, in other words, did they ground every single aircraft that they had until the end of the investigation?
So they kind of, it was kind of obvious where the guilt was. Within 30 days of that crash happening, now mind you, they immediately grounded their Ohio fleet. They had a few other Ohio bases, but they weren't too common. Within 30 days, they had packed up all their Ohio bases and pulled their business out of Ohio. I can tell you that we have had some maintenance incidents with our aircraft in our program, and we've caught things proactively, and we have stood down our entire system for days until we could identify whether or not it was an isolated incident or if it was truly a widespread incident. So the proactive programs shut down after major incidents, but certain other programs, they'll shut down for a few days like this one did, and then they'll resume operations.
Thank you.
Yep. Any other questions?
Come on, guys, no more questions? Well, you
Oh,
must
it's
have
just that
explained it
good, right?
perfectly, Justin. I really appreciate the talk. I got some good tips there tonight. I know I'm sure everybody else did too. No more questions, comments, concerns from anybody?
So Matt, I have a question related to Trumbull. So most of the time I'm operating within the city limits, so we're relatively close to the hospital. If there's a patient that we like feel is critical, unstable, and we don't feel comfortable getting to St.E.'s or an appropriate level center, whether it be a stroke or a trauma or whatever, would it be allowed if we portray that across the phone to you guys that we think this would be a good case to that? Number one, they're going to need stabilized, and number two, bird would probably be of good interest, but there's really no good place to set it down in Warren City. So could we utilize the hospital's helipad?
You know, I actually have some experience with that kind of situation working down in East Liverpool. And you know, we called all the time to medical command and said, hey, you need to get a helicopter, but their landing zone later on was put on the roof of the hospital. So when we would come into the hospital, it would have to go through the ED. And most times it was just a brief stop if the bird was already there. I would say you could call medical command and ask them that, but we're also a level 3 trauma center, and I know there's a difference between level 3 and level 1. There's no question about that, but I would have to question whether you would come to the hospital and wait for a helicopter to go to another hospital. I would think you'd have to come in. I'd have to look at the legal end of that.
Yeah, and Matt, I'll just kind of chime in with what I've seen with some of the trauma centers down here. We have a lot of level 3 and level 4, and sometimes our aircraft is not on scene when EMS gets there. And if there's a patient that needs specialty services, but that hospital offers some level of that specialty service, and especially at Trumbull where the helipad is directly adjacent to the emergency room, at least it was when I still was there, that's one of those situations that going into the ER for a quick evaluation to satisfy EMTALA, and if there's immediate life-saving interventions that need to be made, they can. And that's maybe something that if you call medical command, you say, hey, I'm thinking of flying this patient. I'm coming to you guys. Do you want me to keep this helicopter coming based on what you're hearing with this patient? Because you can keep that helicopter coming depending on what their dispatch says. and they can arrange a quick transfer to St. E's because St. E's is never going to say no to a trauma. They're a level 1 trauma center. They are always going to accept a trauma. So you're not going to have an issue finding a receiving physician or hospital. And then that way the ball's kind of already rolling, but that's something that's going to need very specifically stated to medical command and to that ER physician. So they're kind of aware what you're offering up and what you're trying to accomplish. The MOUs that we have with hospitals in West Virginia are traditionally for off-site helipads. So they're separated from the hospital by like a parking lot or something. So it usually requires an ambulance transport to and from the helipad. So that's one of those things that it makes it a little bit easier to justify those situations when you're not right next to the ER.
So would I be right to, because Akron Children's is about 52 minutes to an hour away, and the level 1 trauma center for kids is Rainbow's Maine, which is about an hour 20 minutes, depending on traffic, time of day, and everything. So would you consider that if we have a critical child, that we know that they need specialty resources in our, I guess we're maintaining stability, would that be a time that it would be appropriate to get a bird from either STAT or one of those specialty centers to come down and get that child?
So that's a tough one just because each situation's a little bit different, and you're probably going to hear something a little bit different from each physician. And I know Matt's probably going to bring this up to the Trumbull people, because, you know, this is something that's a lot easier to war game and iron out ahead of time. So that way there's a lot less hurt feelings and stepped on toes when it actually does happen in real life. So each physician's going to say something a little bit different. And I guarantee you, each physician's going to say something a little different based on their comfort level of taking care of an acutely ill child. But they're probably also not going to want the risk of having a child that was essentially almost in their ambulance bay that they never evaluated. So that's something that, you know, you'll probably have to get with Matt or your agency and have that agency work with Matt to figure out the legalities of that, because I'm not an attorney in real life. I just play one on YouTube, so I can't offer a true legal opinion. So that's something that's going to have to truly be something that comes from the hospital's risk management department and legal department. So unfortunately, I really can't offer an opinion one way or the other on that.
Okay, thank you. I appreciate that.
Justin,
Yep.
I have a similar question.
Yeah.
This is Lauren. Lauren Tanner.
Hey. What's up?
If you, yeah. So similar question along the same thought process. So some of our more rural communities, like for instance, for lanes, if you're out west, sometimes it can take 35 to maybe 40 minutes for like say a CVA or a severe trauma. Most of the time we just throw them in our truck and go. But when you have a patient that would benefit from a comprehensive trauma center or like a comprehensive stroke center, we had a patient that had a complete arm amputation, and at the time we had talked about flying them to a center where it could be put back on because of the person's age, and like the level 1s did nothing with it. They just immediately disregarded it. So we didn't know that, but it came up in our conversations, our quick conversations on scene, that the flight crew still might choose to fly to Maine, St. E's, Maine. Is that is that something that they can do? Like, at that point, we decided not to call an ambulance, not to call a helicopter, because the extrication was simple. And I mean, I can get them to Maine. The benefit to the helicopter would be to going to a comprehensive center, but they said the flight crew could deny that location request.
Yeah, so I'll tell you that based on our law in West Virginia, and I'm sure it's based on trauma destination protocol in Ohio, we were actually mandated to take the patient to the closest, most appropriate trauma center, which for us was the closest level 1. Our dispatch center usually told us what the closest level 1 was. If it was a few miles difference, we would traditionally try to take it to one of our owner facilities, just because we knew their capabilities a little bit better than someone else. But if you're in that situation, that if you're in like North Jackson or something, naturally St. E's is probably going to be your closest to level 1. And most flight crews have the direction from their medical director that they're to transport to the closest to level 1 trauma center. And that kind of stems A, from the CDC trauma destination guidance, and B, it stems from a legal liability thing, because it's really tough to justify why you transported to level 1 trauma center further away, when technically in the eyes of the American College of Surgeons, they're one and the same. Now, you and me can both agree until we're blue in the face that all level 1 trauma centers are not built the same. Like, I completely agree with you that the care delivered at UPMC Presbyterian is going to be different than West Virginia University Medical Center and different than Cleveland Clinic, Maine. Like, each level 1 has their own quirks and they're built a little bit different, and they all specialize in a little bit of different types of trauma. But from a legal standpoint, they're going to go to the closest. And then also, aeromedical is a common target of anti-kickback statutes. And when we preferentially take trauma patients to further trauma centers that we are financially tied to, that can kind of be looked as a little bit of impropriety, like we're trying to double dip a little bit and keep our owners happy. So we try to make sure that, you know, we're just following the trauma triage guidelines, which 9 out of 10 times is transport to the highest level trauma center that's the closest one to you. So the only time that we would not do that, and I've had this personally happen to me with a slightly similar situation, we had a 9-year-old girl in a boating accident in Western Maryland, and she had 3 distal fingertips amputated. And it was one of those things that we didn't have a hand surgeon on duty that weekend at our level 2 pediatric trauma center in Morgantown. How that happened, I don't know, because that's a level 2 requirement. But that was one of the times that we found the more appropriate trauma center was Pittsburgh, based on the patient's clinical condition. So going to the closest level 1 is not an outright requirement, but it's what you're going to find the flight crews doing the majority of the time.
Right. But I mean, that's the same thing with a stroke. If you are 30, 40 minutes away with an actual VAN positive stroke, it might be better to fly them to a true comprehensive than take them to St. E's, where they're going to play around with for hours.
Yeah, and stroke is one of those things that it's really easy to justify going to those larger centers, because there's not a ton of comprehensive stroke centers. So it's really easy to justify, hey, we passed up these hospitals that are all tertiary or primary stroke centers in lieu of taking them to a comprehensive, because there's so few of them. Like WVU is, I think, one of only 2 comprehensive centers in the state of West Virginia. So if you're having a large vessel occlusion and you're north of Charleston, West Virginia, I guarantee you're going to end up in Morgantown. That's an easy one for us. Trauma centers, on the other hand, they're kind of frequently placed. I mean, there's a lot of trauma centers around. I think Larry's putting up the map right now. So you're going to go to the closest one that can handle you, and that may or may not be the one that can truly handle the patient's clinical condition to what we would expect. But that's what we're bound by trauma triage destination guidelines.
Okay, that makes sense. Because I mean, you want to get the patient what they need. And I'm not going to lie, we were very disappointed that they're like, oh, just throw the arm in the corner. And I was like, okay, that's like, they didn't even think about reattaching it. And it was a very young person. So,
yeah, and I can tell you too, that's, I've had such a hot and cold experience with reimplantation of amputated limbs. We have some vascular surgeons that we have a really aggressive, nasty wound that I'm thinking would never get reimplanted, and they go for it. And then I have somebody get their arm lopped off in a shear, and it's a completely clean break with essentially intact vasculature, and they never even try it. So limb amputations and reimplantation are really weird for whatever reason. That's something I've never seen agreement on.
Well, they just kind of told me, they're like, you should have took him to Pittsburgh. And I was like, okay, like we tried to think of that, but and then also you brought out that helicopters are not allowed to take them. They have to take them to the closest trauma center. So
Mm-hmm.
unfortunately, from personal experience, my husband was involved in a crash between here and Cleveland, and the helicopter service that came, I spoke to the flight crew, and they were within equal distance of St. E's, and they said they had to go to their hospital because they only return patients there.
Yeah, and that legally is a statement that I would never say as a flight crew. Do I have preferential treatment to my owner medical center in Morgantown? Absolutely, because I work with them every single day. I know their trauma capabilities, but I'm also respectful of the fact that I don't want to put my program in a legal bind, because it looks like I am preferentially shuttling patients that they're going to be able to bill a lot of money for just to that hospital because they own me. Each program kind of has their own guidance, and the one benefit to West Virginia is it's written into state code. Like, I don't have an option in it. If I'm equidistant, I have a little bit of leeway, but if it's a 10-mile difference, I have to go to the further trauma. I have to go to the closer trauma center. So I can't speak for every program. Now, I will say some of the hospital-based programs that are truly owned, like their hospital employees, they might have some medical direction quirks that say in order to maintain proper medical direction and patient follow-up, they want them to come back to their owner facility. But nationally, that's the rarity.
Well, surprisingly, the hospital he was transported to, I had a worse experience than you could imagine than at St. E's, Maine. So, like, I had actually requested to go to Maine, but they said, no, we have to take him back. That's the only place we transport. And I was like, oh, okay, thank you for that. So,
Yeah, I'm assuming
went to
that
Cleveland.
hospital was in the land.
It was in the land. Yeah, it was awful.
Yeah, just broad assumption.
Yep. Well, thank you for clarifying.
Yep, not a problem.
All right, good discussion, man. I appreciate everybody jumping in and giving their opinions and asking their questions and everything. That makes for some good learning. I appreciate that. Any other questions?
Hey, Matt, it's Nick Graff. I got one more thing for you. EMTALA specifically for 911, if I'm using a hospital's helipad, is allowed. The hospital does not have to see them. However, every hospital has their own policies, so some may request that. But if I'm using a helipad at a hospital because they need a different hospital and it's an emergency 911 call, that EMTALA says the hospital is free and clear. It's a little bit different when like a nursing home's using it for a transport or something like that.
Well, yeah.
That's the one thing that we found where EMTALA gets dicey, and Matt had this experience in East Liverpool when they moved from an off-site helipad to one on the roof. When you have to physically enter that hospital, all bets are off. Because if you have to walk through that emergency room with that patient, then they're going to be in some legal hot water if they don't at least look at that patient. Now, if it's an off-site and you never enter the hospital, that's where EMTALA, you have a little bit more ground to stand on.
Well, that's good information. So when Trumbull gets sued for EMTALA violations, I can tell him that Nick Graff said it was good.
Go for it. I mean, that's my interpretation, but I'm a YouTube lawyer.
Listen, man, getting that YouTube Juris Doctorate degree, that thing was easy.
Doug Wolfberg from Page Wolfberg and Worth is going to be on next Thursday, so that'd be a good question to ask for him.
Yeah.
Yep.
All right, guys. Well, if everybody's done and satisfied, We'll catch you Thursday night at 6 o'clock. Justin, I really want to thank you again, man. I really appreciate everything you've put into this program. It's been a great help.
Yeah, not a problem. I'm just glad I could help.
And thanks everybody else for spending some time with us tonight. Have a good night, everybody.